All right, let's take a look at number 5. So we're supposed to find the derivative when x equals 1, but it looks like we have to use implicit differentiation, so we might have to figure out what y equals when x equals 1. I'm looking at number 5, so let's write it down. So I need to know what dy dx equals when x equals 1. However, I'm fairly certain I'm going to need y, but I guess I'll worry about that in a little bit. So perhaps I think I know that I need y just because I've done a lot of these problems, so let's just pretend like we didn't know that and keep going. So let's take the derivative, and we're taking it with respect to x, so this would be 6x. Then we have to use the product rule. First, d second, that's implicit differentiation, plus second, d first, plus 2y dy dx equals 0 because the derivative of 2 is 0. So that's all good. Now I'm going to solve for dy dx. So I don't have any like terms right away. I'm going to move that and that over, so I get negative 6x minus 2y, because I'm subtracting that over. And I'm going to factor this out. So I have dy dx and a 2x plus 2y. So far I think that's okay. And then I will divide by this. So I get dy dx equals negative 6x minus 2y, all divided by 2x plus 2y. And now I need to plug in x equals 1, but I also need what y is. Like here I have x's, but I also have y's. So I have to figure out how do I get that? Well, I go to my original equation, I plug in x, and see what y is. So let's see if we can do that. If I plug in x to be 1 into the original, then I get 3 times 1 squared. So that's 3 plus 2y plus y squared equals 2. This is a quadratic. I can just solve this. So y squared plus 2y, if I subtract, plus 1 equals 0. Factor that. What times what gives you 1? When add together you get 2. Well, that's just y plus 1, y plus 1. So y equals negative 1. Yes, hopefully that works. Y squared, y, 2y, yep. So there we go. I have an x, but I need to plug it into my original. That's, I think, what you were looking for. I got stuck and I tried factoring the first, I got stuck and I also tried drawing. So the point is find the derivative, which we did, and plug in x equals 1. But we found out that we need y values as well. So we got to figure out those y values from the original equation. So when x is 1, y has to be negative 1. So now I can plug it in and figure out the answer. And then I don't actually want to plug it in, so you can plug it in. But that's how you do that. Let's look at this number 6. Find the point of, or points of inflection of the graph. I think what you're saying is y equals 5x to the 4th minus x to the 5th, and we're supposed to find the points of inflection. The points of inflection are when the second derivative changes sign, which means when concavity changes. So I have to figure out the second derivative and maybe do a sign chart. So that's what I'm going to do. I'm going to take the first derivative, y prime, and that gives me 20x to the 3rd minus 5x to the 4th. And the second derivative is 60x squared minus 20x to the 3rd. That's a 0. And I guess I'll just factor it to make it look nice, because I am going to be setting it equal to 0. So I'll factor out a 20x squared. And that would be 30 minus x. I think that's right. Let me just double check. Now, what did you do? So first I got the second derivative, then set it equal to 0, and got the critical point 0 and 1/3. I didn't get 1/3. So there's what it is. I got 30, right? Because if I set this equal to 0, then I get a double root at x equals 0. So x equals 0, it happens multiplicity 2, that doesn't matter. And also x equals 30, not 1/3. Something went wrong for you. Maybe it went wrong for me. If I factor out 20 x squared, yeah. So I think there's your problem, 0 and 30. And I got confused because I plugged in the x in the equation. The answer. So 0 and 30. What is it? Find the inflection points. So it's either at 0 or at 30. Hopefully, well, I guess I can find this one and look. So now what I'm going to do is do a sign chart at 0 and 30 because those are the critical points for the second derivative. My test points will be -1. Let's do 1 and 31. And I'm plugging it into the second derivative. So if I plug in -1 to the second derivative factor forms is the easiest. I want to know if it changes sign. I already know it equals 0 here, but I want to know if it changes sign. So if I plug in -1, this is always positive. This is positive, so that's going to be positive. And then plug in 1, that's always positive. 30 minus 1 is positive, and so no sign change there. And then plug in 31. Well, that's positive, that's negative, so I get a negative. So there is an inflection point at x equals 30. There you go. I feel like, yeah, something happened with the 1/3. All right, I'm going to end this video and then answer your last question in another video. Your last question is the limit definition of the derivative.